Bonjour, welcome to Wahsa Citizens Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate. If you'd like to participate live today, you are welcome to call the Wahsa studio at 1-800-465-7144 or 737-4017. Then you can ask me questions and I can clarify things. You can listen on the radio at 91.9 FM or on the television at Bell Express U channel 972. You are always welcome to join me live through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled on Monday through Thursdays at 11 till 12 in the morning, and we are now in week 6 of our 9-week course. At this point, you should be submitting some work. So the work to submit are not the support questions. Those ones are not for marking. The ones marked with the pencil icon, they are just practice questions that you can decide which ones and how many to do. If you're understanding a concept, feel free to skip questions. However, if you need more practice, let me know and I can send you some. The answers are in the back of the booklet, so please check your work to make sure that you're on the right track. However, we have found mistakes. So if anything isn't lining up, please let me know and we can check to see if that's an error in the booklet. The ones marked with the key icon are the questions to submit, the ones that I will mark. So please do all of those questions and show all of your work, your steps, and your thinking so I can give you credit for everything that you understand. And yes, how to submit your work for marking. There are 3 methods. The first is to scan and send your work in electronically. That's probably the fastest way. So scan your completed work in. If you have a smartphone, you can use the iPhone's Notes app or the Android Google Drive app. If you need support with that, let me know and I can walk you through it. You can then send your work through email to studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger at bslatewahsa. The second method is to drop the work off in Sioux Lookout. At our office 74 Front Street, we have an outdoor mailbox where the big red building next to the post office, and there's a small white mailbox next to our side entrance. We are currently working remotely, so it may take me a few days to get you, but I will mark it as soon as I can and get back to you promptly. It is to hand your work into your DEC. Your DEC can either send your work in through the Express or fax it to 807-737-1732 or toll-free fax 1-800-463-7852. Always, if you have any questions or concerns, anything you're having challenges with, please contact me. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. My Facebook is bslatewahsa. My phone number, you can leave a message for me at the main office and I'll return your call. The number is 807-737-1488, or you can call toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m. and I'll go back to you as soon as I can. Connecting with me through Facebook, you can either you can friend me on Facebook and then follow me on my YouTube channel, which are both called bslatewahsa. All of our radio Zoom classes are uploaded shortly after airing, and I share them on Facebook. There are also short videos on my YouTube channel that help with confusing concepts or common errors. So that's a great place to check if you are struggling with concepts. Math is a very visual subject, so connecting with the videos, either joining me live through the Zoom link or watching the replays on YouTube, is going to set you up for the most success. It's really hard to understand everything that I'm doing just by listening. So being able to watch it and see where I'm placing numbers, or how I'm organizing my information, how I'm making connections visually is really going to make the most sense. If you don't have access to consistent, reliable internet, let me know and I can send you a USB key or something to give you all the lessons so that you can still watch them. All right, we're on day 21 of our course and we're diving into lesson 14 today, which is trigonometry and problem solving. So our learning goal for this lesson are such that at the end, you will be able to say, I will be able to identify the trigonometry strategy needed to solve real life situations. And I understand the difference between the angle of elevation and the angle of depression. The success criteria are that you can say, I can comfortably and confidently identify which trig strategy to use depending on the situation. And I can draw a situation, including if an angle of elevation or depression is involved. All right, let's activate our brain with some mental math. I'm not a fan of the classic Mad Minute tests that many of us experienced in elementary school. So instead of doing those stressful timed tests, we work on strategies that engage your brain and that are transferable into various situations to help you become more comfortable with numbers. Our question today is 24 times 9, and we are using the strategy of breaking factors into smaller factors. So 24 and 29 are factors, are two numbers that we're multiplying to get a product. And we can break those numbers up if we don't know off the top of our head what 24 times 9 is. We can break those into smaller numbers that might be easier to do. So I am thinking about what might be more accessible. So what comes to the top of my head is that 9 is 3 times 3. So 24 times 9 is the same as 24 times 3 times 3. So 24 is really close to 25. So if I know that 25 times 3 is 75, then 24 times 3 is going to be 72. And then 72 times 3. I can then say, okay, well, that I know that 2 times 3 is 6, and 70 times 3 is 210. So that's going to give me 216. So 24 times 9 is 216, because I broke it up into numbers that were a little bit more friendly for me to multiply. You could do it completely differently. You could have done, so 24 times 9, we could instead have broken up our 24 into 3 times 8 times 9, or we could have done 24 times 9 could have also been 4 times 6 times 9. There's various different ways that we could have done that. We still always would have gotten to the same final answer, but maybe one of these methods would have been a little bit more straightforward for you, possibly. And you can, that's the joy of breaking factors into smaller factors, is that there's flexibility. You can do what makes the most sense for you. All right, mine's on. Let's engage in some prior learning and see what skills we need for today. So something I noticed in our IL booklet is that they use a couple of different notations that we haven't used yet for angle notation. So I just wanted to clarify what those different angle notations are. They all mean what they mean, so that when you come across those questions, you know what's going on. So we have a triangle, ABC. It's not a right angle triangle. It's nothing special. It's just a triangle. So our first way of talking about angles are the one that we've been talking about most frequently on our lessons, is when we say angle A means the angle at vertex A. So that's the way that we've been talking about it, where we just have the angle symbol and the capital letter A is talking about the angle at our vertex A. The second method that we could use is where we say angle ABC, and this means the angle at vertex B. So how we think about it, the way that my diagram has shown, is that we start at A, we go to B, and then we go to C. And so that angle that's contained, the angle that we go to in the middle, that's the angle that we're talking about. So if you see that notation where it says angle ABC, we're talking about the angle at the middle letter, at angle B for this example. And then our third method is that we could use a Greek letter, is very common to be used as an indicator of an angle. So here for my example, I have the Greek letter theta, which looks like a 0 with a line across the middle, a horizontal line. And that's sitting at, indicating that's sitting at an unknown at my angle C. And so that is saying that's the angle that we're looking for, the unknown. Theta, beta, alpha are the three examples that I have shown up here, are very, very common to use in geometry and to use looking for angles. So those are very possible ones you may see. There's lots of other Greek letters that could be used. These are the ones that are most common when we're introduced. The letter that is actually in your IL book, I don't know. I looked it up and it said that it was a J letter. And then I continued to do some research and there's supposedly no such thing as a Greek letter J. So I don't know what it's called. I wasn't able to figure that out. So just the symbol that is in your IL booklet, I don't remember what page it's on. I'm assuming that it's a representation to say it's asking for the angle, even though I don't know what the symbol is called. You can just replace it with a letter, the letters that we use in English, and that's fine. I will update that so that we're not using a symbol that we can't define. And that's the notation. So they all mean the same thing. They just mean they're different ways to notate an angle. All right, so let's explore some new concepts. Really today, we are reviewing the strategies that we have been learning the last few lessons and figuring out how to problem solve with them. So when will you use this in real life? We're improving our problem solving skills. Problem solving is the basis of most of the ways that we interact with each other. Most of our employment and our relationships are based on problem solving. It's really, really key to our world. And so we're improving those skills. Maybe mathematically, you don't need to know the steps of solving a problem with trigonometry, but similar, these sort of how we can break down a problem can help us in our lives, in our day-to-day lives. All right, so what are the steps to solving these problems? So the steps to attacking a trig word problem, so trig for trigonometry. So how we, when we find a problem that we need to use trigonometry, how we figure out what to do. So first, I strongly encourage drawing a diagram or at least visualize what is happening. Being able to picture what's going on is really going to help you. So then two, figuring out what information you know and what information you need to find out is key. You need to know what the question is asking and what information you already have in order to figure that out. And you're going to choose your strategy. So we have three strategies that we've been learning about. So we have the primary trigonometry, which is the SOHCAHTOA, or sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tan equals opposite over adjacent. We have our sine law, which we've learned about, and then our cosine law as well. So those are the three strategies that you're going to choose from, depending on the information that you know and the information that you are trying to find. You're going to have to pick which of those strategies to do that. Then you're going to use the formulas to complete the calculations. You do not need to have the formulas memorized. They will be provided for your exam, and it is something that you can look up, completely reasonable to look up that information if you don't have it, but you need to know how to apply and how to use the information that you have to apply it to the formulas. And then I strongly encourage you to write a sentence to make sure you answer that your number actually answers the question. So often these questions have multiple parts. And so you have to refer back to the question to make sure that you actually got to the end of the question. So it's really important to make sure that what your solution is actually answers the question. And writing a sentence helps you remember to do that and helps you just clarify what your number actually means. Something to note is that there might be more than one way to solve the problem. You can do what makes the most sense to you. You get to pick. The only case would be if the question states what strategy to use. If we're trying to get you to practice something particular, or I'm trying to evaluate your understanding of a certain thing, I might say, use the cosine law to solve this. Then you're expected to use the cosine law. But if the question doesn't say it like that, if it just gives you a problem and says solve it, you can pick which method. There may be more than one method that can actually work, and that's fine. I'm not going to guarantee, there's not that you can't use every method in every question. But sometimes you can use more than one, and it's okay to pick a different one if it makes sense and if it's accurate. Okay, so those are the steps, but how do you know which strategy to choose? You can't just pick at random, you want to know depending on the information that you have. So if in terms of primary trigonometry using SOHCAHTOA, where sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent, those ratios, you're going to do this when you have a right angle triangle. You can only use primary trigonometry, those relationships, those ratios, when you have a right angle triangle. And then you can use the sine, cosine, and tan ratios. So that's a good thing to check for first. Do you have a right angle triangle? If you do, see how you can use primary trigonometry. It's probably the simplest approach. Sine law, you use when you know two angles and a side. So then you can solve for any side using the A over sine A equals B over sine B equals C over sine C. Or when you know two sides and an angle, where the angle is opposite one of the known sides, and then you can solve for the other opposite angle, which is sine A over A equals sine B over B equals sine C over C. Again, to use the sine law, you do not have to have a right angle triangle. It can be any kind of triangle. And you can use either of these formulas in any situation. Just these are the way that I've laid it out are the ways that are going to make it easier to solve and have to do less algebra. Then third, we have our cosine law, which again, you can use for any triangle. It does not have to be a right angle triangle, any triangle, but you use it when you know two sides and the contained angle, so the angle between the two sides. Then you can solve for the unknown side by doing c squared equals a squared plus b squared minus 2ab times cos c. Or when you know all three sides, you can solve for any unknown angle using cos c equals a squared plus b squared minus c squared all over 2ab. Now, all of this, if any of this is new to you, then you need to go back and one of the other videos, I'll link them in the show notes so that you can quickly get to them. We are not going over why these make sense or how to apply these. Right now, we're just problem solving with these tools. We're not understanding those tools in depth. So if you need a refresher or you missed a lesson, go back and go to the videos about these so that you can really understand what they are before trying to do the problem solving. At this point, we're collecting all those skills and those tools and applying them. But if you don't understand one of those tools or all of those tools, then this lesson is not going to make any sense. So then you need to go back and understand that first. Okay, so here's an example. Choose the best strategy to solve each triangle. We're going to go through a couple of examples and figure out how we know what strategy to use. So we have a triangle ABC. We have some side lengths that one's 21 feet, one's 14 feet, and one's 16 feet. We do not have a right angle triangle. So that's the first thing. We don't have a right angle triangle, so we're not going to do primary trigonometry. We're not going to do the SOHCAHTOA ratios. We are given three sides, so we use the cosine law. Oh, I would strongly suggest screenshotting this screen that I've just come back to, the how do we know which strategy to use, because it has it all there together that you can refer to it. So screenshotting it, printing it, taking a picture of it on your phone, some way capturing this page means you can refer back to it as you're working through the problems in your booklet. Okay, so we have three sides, so we know we can use the cosine law. So we can solve for any of the angles using cos c equals a squared plus b squared minus c squared all over 2ab. That would be solving for angle C. We could then replace A or B to solve for the either other angle. The question only asks to choose which strategy. We're not actually going to solve it. So we know that this example, we're going to use cosine law. All right, we have another triangle. We have a right angle triangle ABC with a side length of B to C, a side length of 8 and a side length of 12. So because we have a right angle triangle, we're going to use primary trigonometry. And then depending on what we want to do, so we can solve the third side by using Pythagorean theorem. Because it's a right angle triangle, we can do c squared equals a squared plus b squared to figure out the side length of that. And then we can solve for any of the angles using sine or opposite over hypotenuse, cosine equals adjacent over hypotenuse, or tan equals opposite over adjacent. depending on your reference angle, you would pick that, and then you could solve for any of those, for those two angles, and that's how you'd solve for the side. Once you found the side, you could also solve for the other side. That would work once you found the angle. All right, so then next triangle, again, choose the best strategy. We have a triangle ABC. It is not a right angle triangle. We know that angle A is 88 degrees. We know that angle C is 58 degrees. And we know that side A across from angle A is 14.5 meters. So because we have two angles and a side that is opposite the side that we know, we can use the sine law. So we can solve for the third angle because we know that interior angles add up to 180 degrees. So angle B is going to be 180, take away 88, take away 58. And then we can solve for any of the unknown sides because then we would know all of the angles. We could solve using A over sine A equals B over sine B equals C over sine C. And that's how we can solve that triangle. All right. So now we're going to talk about the angle of elevation and the angle of depression because that's often comes up in our questions and we need to understand what that actually means. So the key is that we look with our eyes and not with our feet. So when we're measuring angles, we also need to think about if we are looking up or down to see an object from eye level. So here is a diagram where we have an icon of a human and the angle of elevation is, to figure it out, what we do is that we look straight out from to the horizon. So we're looking straight out at eye level, and then we look up to an object, and that's our angle of elevation. So the angle in which we had to look up is our angle of elevation. So from our eye level up is angle of elevation. So here's an example of what that might look like. Javier and Seema are 325 meters apart, watching a hot air balloon above them. Sorry, someone's knocking my door and I'm going to ignore them. Javier measures the angle of elevation to the balloon to be 54 degrees. Seema measures the angle of elevation to the balloon to be 38 degrees. How far to each person is each person from the balloon to the nearest meter? So first thing we're going to do is we're going to draw ourselves a picture. So here we have a picture of two people who are 325 meters apart, and there's a hot air balloon that they're looking up at. We know that between them, so the angle of elevation from Javier is 54 degrees. So from the horizon up to the hot air balloon is 54 degrees. And then the angle of elevation for Seema is from the horizon up to that hot air balloon is 38 degrees. So we have two angles and a side, so that is known. So we're going to use the sine law. I'm just labeling my triangle. I've picked letters that go along with my people and my balloon. So J for Javier, S for Seema, B for balloon, and then corresponding small b across from big B, small j across from big J, and small s across from big S. So the thing is that we don't have any matching sides and angles. For the sine law, we need to have a side that is across from an angle that we know. So we need to figure that out. So the first thing we're going to do is figure out what is angle B. So the angle at the balloon, we're going to figure out because a triangle has 180 degrees. So we're going to take away 54 and 38, which we know, which is left with 88. So our angle at our balloon is 88 degrees. So now we can figure out our distances. So the second thing we're going to do is we're going to figure out the distance from Javier. You'll notice from your diagram, your distance for Javier is actually what is marked as S, right? It's the side across from Seema, so it is our side S. So we're going to use that information opposed to using the information that is next to Javier. That's why, again, why it's really, really important to draw yourself a diagram. So S over sine S equals B over sine B is how we're going to figure out the distance for Javier. We substituted our numbers. So S over sine 38 equals 325 over sine 88. So then S equals 200 meters. I'm not showing the steps to solve it because we've done lots of that practice. Go back to the previous lessons if you need more practice to understand how I got there. So the distance for Javier is 200 meters. So now we need to figure out the distance for Seema. So again, the distance from Seema to the balloon is the distance J. So J over sine J equals B over sine B. It is best to use the information that we already know. We could have compared it to the side S, but it's best to use the information that we had to do the least number of calculations, because then if we made a mistake finding side S, it's less likely that we're going to make a mistake for finding side J. So then we substitute in the information that we know. So J over sine 54 equals 325 over sine 88. So J equals 263 meters. So now we have to check to make sure that we answer the question. The question is, how far is each person from the balloon to the nearest meter? Therefore, Javier is 200 meters from the hot air balloon and Seema is 263 meters from it. There we go. We answered the question. But again, sometimes we have lots of parts that we need to do. So organizing your information is really important. All right, so now we're going to look at what the angle of depression is. So we just looked at the angle of elevation. So straight from the horizon, then up, the angle of depression is what we're going to look at now. Again, we look with our eyes, not with our feet. So we're measuring the angles from our eyesight, our eye level, looking up or down. So the angle of depression, to find that, is we are looking again straight out to the horizon, and then we're looking down at an object. I didn't fix that, my bad, sort of essential. We are looking down at an object, and this is the angle of depression. So looking straight out and then down, the angle that we look down is the angle of depression. All right, so let's look at an example. From one end of a bridge above a railroad track, the angle of depression to the tracks is 37 degrees. If that point is 112 meters from the track and the bridge is 122 meters long, how far from the other end of the bridge is the track to the nearest meter? So again, these questions can have lots of information. It's really easy to get confused and to mix things up. So drawing a picture, visualizing is really important. You don't need to have graphics. It doesn't need to be beautiful. You don't have to be an artist. Drawing a sketch of a triangle with points is good enough. So I'm drawing objects to help us conceptualize it, but it's all good. You don't need to draw them. So we know that at one end of a bridge above a railroad track, so I'm calling it R, the angle of depression to the tracks is 37 degrees. So straight out from R, then down to the rail tracks is 37 degrees. So that's our angle of depression. So that point is 112 meters from our tracks. And the bridge, the distance of the bridge is 122 meters across. So we're trying to figure out how far from the other end of the bridge it is to the tracks. So we're figuring out this third side of the triangle. Again, this is why drawing a picture is so important, because you can understand what's going on in the picture to help the situation. So we have our triangle now. We've labeled RST. So our corresponding sides are small r, small s, small t. And we can see that we have two sides that we know and a contained angle. So we use the cosine law. So we're going to use c squared equals a squared plus b squared minus 2ab cos c. You can write it out the way that we have it, and then you can just substitute in your values that, like your variables that you know. So r squared equals s squared plus t squared minus 2st cos r. What we're looking for is side r. So then we substitute in our values. R squared equals 112 squared plus 122 squared minus 2 times 112 times 122 times cos 37. So then r squared equals 5,602.89. So then we take the square root of both sides, and then r equals 74.9 meters long. And that's how we would solve this problem. So again, check to make sure we've answered the question. Therefore, the other end of the bridge is 75 meters from the track. And that's what the question has answered. Perfect, we're good to go. All right, so if you'd like to pause the video now and do some support questions on page 35 to 36, questions 1 through 4 are the questions that we just sort of covered, the content. We're going to now do a recap of what we learned this lesson, and then we'll get into some practice questions. So let's consolidate. So the highlights of lesson 14 for trigonometry and solving problems. We need to identify the trigonometry strategy. So the first would be primary trigonometry, where we have a right angle triangle where we can use SOHCAHTOA. The second would be the sine law, where we have two angles and one side, or two sides and one angle that is opposite the known side. Or cosine law, we have two sides and one contained angle, or three sides. We pick, depending on our situation, we pick which of those strategies to use. And then we know that the angle of elevation is the angle of sight level from the horizon, then up to an object, and the angle of depression is the angle at sight level from the horizon, then down to an object. So depending on your situation, that language might show up, and we know that that's how we can figure out how we can visualize what's going on in our situation. All right, so our success criteria is one that you can comfortably and confidently identify which trig strategy to use depending on the situation. It may take some practice, but I believe you can do it. And two, you can visualize and draw a situation, including if an angle of elevation or depression is involved. So really practicing understanding that language of elevation is up and depression is down. All right, let's do some practice questions. So number one, a pilot is flying from Thunder Bay to Dryden, a distance of approximately 320 kilometers. As the plane leaves Thunder Bay, it flies 20 degrees off course for exactly 80 kilometers. After flying off course, how far is the plane from Dryden? So let's draw ourselves a situation. So we have Thunder Bay, I'm just going to call it T, to Dryden. D is 320 kilometers. The plane, instead of driving directly there, flies off course for 80 kilometers at an angle of 20 degrees off course. So we're trying to figure out how far now this plane is from Dryden. Okay, well, we have two sides and a contained angle. So that means that we're using the cosine law. I'm going to label my third corner. I'm just going to label it C for off course. It really doesn't matter. But just so that I can organize my letters so that I know what I'm doing. So I'm trying to find side T. So I'm using the cosine law. So T squared is equal to C squared plus D squared minus 2CD times cos of angle T. So then now I substitute in what I know. So T squared is equal to C squared, which is 320 squared, plus D squared, which is 80 squared, minus 2 times 320 times 80 times cos of 20 degrees. We're going to use our Desmos calculator so that you can see what I'm doing. You can use your own calculator, of course. My calculator's in degrees, which is always essential. I do 320 squared plus 80 squared minus 2 times 320 times 80 times cos of 20 equals 60,687.737. So 60,687. So T squared equals 60,867.74, I believe was what my number was. Just check it again, make sure I got it right because I didn't. So That is a challenge of, I can't have both open at the same time when I'm writing on my screen. Okay, so then to find t, I have to take the square root in order to cancel off the squared. So I'm taking the square root of 60,687.74. So go back to Desmos to do that. Square root of 60,687.74, and that equals 246.3. So t equals 246.3 kilometers. So we have to check to see, did we answer the question? How far is the plane from Dryden? So the plane is 246.3 kilometers away from Dryden. There we go. Okay. So then part 2, by what angle must the pilot change her course to correct the error? So again, just a quick resketch of what had. So now we're trying to go from where we are off course to figure out how to get back to Dryden. How do we, what angle? Now what angle do we need in order to get to Dryden is what this question is asking. So we're trying to find the angle at C. So I'm going to quickly just remember what my distance is so that I can use that information, 246.3. So I'm going to add that to my new diagram, 246.3. So I'm trying to find the angle C. So I know my side length across from C, and I know my angle T, and now I know my side T. So I know two sides and an angle across from one of my sides. So that means I can use a sine law. So I'm looking for an angle. So I'm going to say sine C over little c is equal to sine T over little t. I'm looking for the angle. So that's why I picked this option, because angle C is on the top. It's going to be easier to solve for. So now I'm just going to substitute in sine C over 320 is equal to sine T, which is 20 degrees, over 246.3. Now to solve for sine, I'm going to multiply both sides by 320 to cancel off the 320 so that I can isolate for sine C. And do on my Desmos calculator. So 320 times sine 20 divided by 246.3 equals 0.4446. So I'm just going to round that to 0.4444. Remember, because when we're trying to find sine of something, we want to round it to 4 decimal places in order to get a most exact answer. So then in order to find sine, or in order to find C, we need to do sine inverse. So sine inverse of 0.4444, go on our calculator, have to go to our second function to get sine inverse, and then 0.4444 equals 26.38. So our angle C is 26.5 degrees. So by what error must the pilot change her course to correct, or what angle must the pilot change her course to correct the angle? So she must change her course by an angle of 26.5 degrees. Perfect. All right, next question. Question 2, if an archer is 5.7 meters from a target and the bullseye is 50 centimeters below their eye level, at what angle does the archer need to shoot to get a bullseye? Again, draw your picture to figure out what's going on. So we've got a person who's an archer. So we know that the target, so that we know that they are 5.7 meters to a target, and the target is 50 centimeters below their eye level. We're trying to figure out at what angle they need to shoot in order to hit the bullseye. So we're trying to find the angle. So one thing to note about this question is that we have 2 units of measurement. We have 5.7 meters and we have 50 centimeters. We needed them to be in the same units in order for our ratios to make sense, in order for our answer to make sense. So I'm going to change 5.7 meters to be 570 centimeters. I just multiplied it by 100 because there are 100 centimeters in a meter. So you just need to make sure that your units are the same. So then here for this one, we can assume that the target is at a 90-degree angle, right? From our sight line, we're looking directly at it. It's going to be straight up and down. So we're trying to find the angle that they need to shoot at in order to hit that bullseye when it's 50 centimeters below. So we have a right angle triangle. We have, so our reference angle A, the opposite is 50 centimeters. The adjacent is 570 centimeters. So opposite over adjacent is tangent. So tan of A is equal to opposite over adjacent. So now we can figure out what to use. So tan of A is equal to 50 over 570. So tan of A equals 50 divided by 570 is 0.0877. So tan equals 0.0877. So then we need to do tan inverse to cancel off the tan and figure out what angle A is equal to. Angle A is my archer, so I don't think I said that. So then on our calculator, we got our second function of tan inverse of 0.0877, which gives us 5 degrees. So angle A is 5 degrees. So the archer shoot at an angle of depression, because they're going down, right? 5 degrees. All right, number 3, determine the height of a cliff H to 1 decimal place. Often we have diagrams where we have multiple triangles, and sometimes it's hard prospectively to know what's going on. So I've drawn this in color. I've given you the picture and I've colored it to sort of try to figure out what's going on so that we can figure out the height of this cliff. We have 2 triangles, one right angle triangle where the height is part of that triangle, and we have an angle of 20 degrees opposite that height. So, and then we have another triangle that how I think about it is these other triangles on the ground. So it's like I have one surveyor, one person standing and looking at measuring from an angle of 20 degrees up to the top of the cliff. And then between them and a second surveyor, there's 100 meters. And the angle from the cliff to that second surveyor is 65 degrees. And then the second surveyor measures the angle between them from the first surveyor to the cliff, and that's an angle of 30 degrees. And so because of these two triangles, we can figure out the height of the cliff. I think this is how surveying actually can work sometimes, but it can look a little bit confusing to figure out what's going on when you have a diagram that has multiple triangles, because perspective is kind of different. So this purple triangle that I have is vertical. It's going up to the top of the cliff, whereas this orange triangle that I have is horizontal. It's on the ground. So these two triangles are actually perpendicular to each other, which is kind of tricky to visualize on a flat plane. Okay, but then how do we figure out what the height of this cliff is? So we are trying to find H in a right angle triangle, and we have an angle 20, which is great, but we don't have any other information. We don't have any other angles, and we don't, well, even if we had another angle, we don't have any other sides. So we can't figure out with primary trigonometry, we need to know a side and an angle, or we need to know two sides. So we can't just do that. So that's why we're going to use the second triangle to figure out this side where they share. We can figure that out. So I'm going to label my first triangle A, B, C, and then my second triangle, I'm just going to add D where my second surveyor is. So we're trying to find side AC because that is the side that is connected to both triangles. If we find that in triangle ACD, then we know that triangle, and that's the same in triangle ABC. So this is what we're looking for so that we can figure out our height. So if that's what we're looking for, we have a triangle with two angles and a side. So we can figure out that third or that side by using the sine ratio, or sorry, the sine law. We need to first find our angle C because we want to have that's opposite our 100 meters. So first find angle C. You can see that there's going to be lots of steps in this one. So first to find angle C, we're going to do 180 degrees, take away 30, take away 65 degrees. So 180 degrees, take away 30, take away 65 is 85 degrees. So angle C in this triangle lying on the ground is 85 degrees. So we can draw that on update our diagram. And now we know that that is across from 100 meters, which means we can use the sine law to figure out the side D that is the one that we need in order to move to the other triangle. So second, we're going to find side D. So D over sine D is equal to C over sine C. So D over sine 30 is equal to 100 over sine 85. So D equals 100 times sine 30 all over sine 85. So D equals, go to our Desmos. So we have 100 times sine 30 divided by sine 85 equals 50.19. We'll just say 50 meters. So this side length here, the side that is joined between the two triangles, is 50 meters. So now to figure out our height, so third, we're going to find our height. And we're going to say, okay, well, from this purple triangle, we have a reference angle of A. And we have our height is our opposite, and our adjacent is the side that we found. So again, tan, because we have opposite over adjacent, so tan A is equal to opposite over adjacent. So tan of 20 is equal to h over 50. So then h equals 50 times tan 20. So on our Desmos, we have 50 times tan 20 equals 18.12, so 18.2. That's to one decimal place. So h equals 18.2 meters. So did we answer the question? Yes, the height, the cliff is 18.2 meters. That's how you do one when you have two triangles like that. All right, practice question 4. Miguel and ZB are surveying an area and are standing on the same side of a birch tree. The angle of elevation from Miguel to the tree top is 67 degrees, and the angle of elevation from ZB to the tree top is 53 degrees. If they are 9.3 meters apart and ZB is closer to the tree than Miguel, how tall is the tree? So we can also have a situation like this. So we have a tree. And this is not what a birch tree looks like, but whatever, we have a tree. And we have ZB, they say is closer to the tree, having a feeling that maybe this is not accurate, but ZB is looking at, is 53 degrees. And Miguel is farther away, and the angle is 67 degrees. Okay, that doesn't make sense. The one that is closer is going to have a higher angle than the one that is farther. So I'm just going to quickly, I made a mistake in naming my characters. So ignore that. And we're going to say Miguel is closer to the tree than ZB. So I'm just switching my people in order to make it make sense. I wasn't paying attention when I was writing the question. Sorry about that. I will fix that in the future, just in order to make my question make sense. Okay, so Miguel is looking at angle of elevation. So from their eyesight up to the tree is 53 degrees, and ZB is 67 degrees. Yeah, I've messed it up. I've switched it the wrong way again. I needed to change my angles, not my people. So the farther away angle is 53 degrees, the closer the angle is 67 degrees. That's what actually matters, not about who is where. And the distance between the two of them is 9.3 meters. That's all the information that really matters. Okay, we are trying to figure out how tall the tree is. So we assume that the tree is growing straight up, so that's 90 degrees angle, and we run out of time. Sorry, we're not gonna have time to go through this question, but that's how you would draw the question based on the information that's given. So sometimes your triangles are on the same side, and then you need to figure out, you need to do 2 steps again in terms of figuring out using the bigger triangle to figure out something, information about the little triangle, or using this external triangle here. We can use we have 2 angles and a side. I'll do a question like this and just put it on my YouTube channel and link it into the show notes so that you can see this, an example like this, just because it's a little bit confusing. So if you're interested in working through this problem, go back to my YouTube channel, go to the show notes, and I'll link it in. As always, if you have any questions, contact me by phone, email, or Facebook. This will be up shortly after this afternoon. I hope you have a very lovely day. Thanks for joining me. Miigwech.